In today's note, we are going to look at factoring trinomials in the form x squared plus bx plus c. So just as a reminder, factoring is the opposite of expanding. And we looked at common factoring in our last note, so we have seen kind of the very basic form of it. And again, let's just remind ourselves the difference between factoring and expanding. Expanding changes a product into terms, or a product of terms into a sum or difference of terms. So if we see in the first example, we have a product where we have two binomials, and when we expand them or multiply, we get basically a sum of terms. And this is something that we've covered before in the past, where we've gone through and we've done this expansion, right? We use the FOIL method or the rainbow method to do this. Factoring, again, changes a sum or difference of terms into a product. So it basically does the reverse. It takes a sum of term or difference of terms and turns it into a product, so things that are multiplying. And that's going to be our goal today. So we know how to expand using FOIL method. Now we're going to try to do the reverse and get back into our two different products. In this note particularly, trinomials, or three terms that are in the form x squared plus bx plus c, are known as simple trinomials. So they're simple because the value in front of the x squared is 1. So whenever that value in front of the x squared is 1, it's known as a simple trinomial, and you can use these steps. So just as a beginning or as a review, let's expand each of the following. So if we want to expand these, we're going to quickly have to use our FOIL method. Right, the first, outside, inside, last. I'm not going to go through the full steps. I'm going to go right through to the end. So x squared plus 7x plus 6. The next one, x squared plus 3x minus 10. X squared minus 7x plus 12. And x squared minus 1x minus 6. So again, you can go through and expand, and then collect or simplify your like terms, and you should get these following examples, or these following answers. What we want to do next is compare the constant term of the trinomial to the constant terms of the binomials. So if I look through, and I'll highlight all of these in yellow, we're going to compare these constant terms with these in our binomials. For the negatives, I'm going to include the sign in front. For the positives, I'm not, but we can assume that they're positive. So what do we notice about all of those numbers? And if you're using the box method, you can, like we talked about in the last lesson, it might be a little bit easier to see the connection, but what we should notice is that for two binomials, x minus x times x minus t, the c value, or the constant in our trinomial, is equal to s times t. So these two constants in our binomials, when they multiply, they become that constant. So we can see that we get the 6 from 6 times 1. We get negative 10 from 5 times negative 2. Negative 3 times negative 4 is positive 12. Negative 3 times positive 2 is negative 6. And when we expand it, it does make sense because those are the only numbers when we collect our like terms that are constant. Right? There's nothing else that we add them to. There's only the one term that is a constant. So that's how we get our last number. Next, what we want to do is compare the coefficient of the x in the trinomial to those constant terms. Again, so what we're going to do is we're going to compare the coefficient in front of the x and compare it to, again, the same thing, these constants in our binomials. And we want to see, is there a pattern, is there a relationship? And we should see that for two binomials, x minus s times x minus t, what we see is that the b value, again going back to this original equation, or this general form, the b value, or that middle term, is equal to s plus t. So when we add those two constants, that gives us our middle number. So that is what we're going to use to help us factor. But first, again, let's try to go through and at least use this idea to kind of predict what our values for b and c are going to be. So in a, x plus 3 times x minus 5, I want to predict what b is going to equal and what c is going to equal, based on what I've seen or what I've noticed in the past. So again, for b is telling me that the two constants in my binomials, when I add them together, are going to equal the b value. So here, if I do 3 plus negative 5, my b value should be, in this case, negative 2. From what I've noticed before, my c value should be s times t, or the two constants multiplied. So 3 times negative 5 equals negative 15. Now what I want to do is I want to expand this. So using my my FOIL method, the box method, rainbow method, whichever one you prefer, I want to expand this and see, are my b values, or is my b value negative 2 and is my c value negative 15? So when I go through and do this, x squared minus 5x plus 3x minus 15, and I simplify, I do see that my b value is negative 2 and my c value is negative 15. So this does seem to work out. So let's go through and do the same thing for the next two. Let's try to see what our b value is going to be and what our c value is going to be. So again, the b value, I've predicted that I have to add my two constants. So 10 plus negative 4 equals, in this case, 6 is what I'm predicting it will be. And c says I have to multiply them together. So it should be negative 40. And when I go through and I expand, or use the FOIL method, I do get x squared plus 6x minus 40. So again, I kind of simplified it and did it in one step, but if you go through and do the full steps, you should see this is what we come to, and our prediction is correct. Same thing for the last one. Let's predict. So b says I have to add my two together, so negative 8 plus negative 1 equals negative 9. C says I have to multiply them together and get positive 8. And if I go through and I expand this, I do see that, again, my prediction is correct. It is negative 9 in front of the x, and the constant is 8. So this pattern, or this prediction of how we get our numbers, is what we're going to use to predict, or to help us factor. So basically what we're doing when we're factoring a trinomial in the form x squared plus bx plus c into the form, or back into two binomials, we are trying to find two numbers, or the s and t, so that when s plus t equals b, and s times t equals c. And once I find those two values, I just plug them back into the equation, or into these two brackets with x, or whatever my variable happens to be. So this method that I'm using is called the product sum method because I'm looking for two numbers with a product of C and a sum of B. So whenever you see me use P and S, that is basically looking at the product and sum. So what I want to do now in the next example is factor. And I want to factor it completely. And when I have my trinomial, I should be factoring it into two binomials. One hint, we want to make sure or check to see, is there a common factor first? And if not, then that's fine. Then we can move on to using our product and sum method. But we always want to look for that common factor first. So first, x squared minus x minus 2, product and sum. So the product, the two numbers have to multiply to C or negative 2, and they have to add to negative 1. So my two factors that will do that, what two numbers multiply to negative 2 and add to negative 1? Well, in this case, it's going to be negative 2 and positive 1. Right? The only numbers that can multiply to 2 are 2 and 1, and then we have to worry about getting the correct signs. So we have either a negative 2 and a positive 1 or a negative 1 and a positive 2. But because we have to have that sum of negative 1, we know that the larger number has to be negative. So my variable is x, and I'm just going to take my two factors, or the two numbers that I found. In this case, negative 2 goes in one bracket, and positive 1 or plus 1 goes in the other bracket. And that's my factored form. So B, I'm going to do the same thing. Look for the product and sum. Two numbers that multiply to negative 12, but add to negative 4. So those numbers, again, this is where knowing your times tables or your multiplication tables is very helpful, because you'll know what the factors or what numbers multiply to 12. If not, you can kind of use guess and check. But you should be looking for nice even numbers or nice round whole numbers. You're not going to be looking for decimals. So in this case, we should find that our factors are negative 6 and positive 2, because negative 6 times positive 2 is negative 12. Negative 6 plus negative 2 is negative 4. Now that I know my two factors, my variable is x, so that's going to be the first part of my brackets. So the first one will be x minus 6, and the second bracket, x plus 2. Again, order doesn't matter in this case because we're multiplying, so you could have the x plus 2 first and the x minus 6 second. Either way, it doesn't really matter. For C, again, product and sum. Two numbers that multiply to 20 but add to negative 12. So in this case, our factors are going to be negative 10 and negative 2. So that means when I factor, this case, my variable happens to be b, so b is going to be first. So it'll be b minus 10 times b minus 2, or the two factors that I found. For D, again, product, sum. So the product has to be two numbers that multiply to 36, and they have to add to 15. So what two numbers do that? Well, we should find 12 and 3. So my variable is a, so a is going to be first, then my two numbers, so a plus 12 will be one bracket, a plus 3 will be another bracket. The next one, again, product, sum, and my factors. So the product is 110. The sum is negative 21. In this case, my factors are going to be negative 10 and negative 11. Negative 10 times negative 11 is 110. Negative 10 plus negative 11 is negative 21. So a is going to be my variable. From the expression, I can see a is being used. then one number, so in this case negative 10, and then a, and then negative 11 will be my second one, and that's factored. Again, product and sum for f, so negative 18 and sum of 7. So a nice thing to think about, if we have to look for a sum and it's positive, chances are, when it's positive and our product is negative, we know we have to have one positive number and one negative number. Because the only way we can multiply to a negative is if our positive, or is if we have one of each, a positive and a negative number. Because our sum is positive, we know the larger number of our two factors should be positive. So in this case, we have negative 2 and positive 9. One positive, one negative number, the positive number is larger. So we should have x minus 2, x plus 9. So again, just some things to help us predict or help us start thinking about what numbers we're going to be looking for. For g, we have 3a squared plus 6a minus 144, and this is a little different. Right? This is different from what we've seen before because the number in front of a, or the number in front of the variable squared, is not 1. So if this is ever the case, the first thing you want to do is check to see if there's a common factor. And what we should find is that there is no variable that's common throughout, but there is a number that's common throughout. And the largest number that's divisible or divides nicely into all of these happens to be 3. So I can take the common factor of 3 out, and then in this case we have a squared plus 2a minus 48. Now we have a trinomial inside this bracket where the value in front of the a squared is 1, so I can use my product and sum rule. So now I'm looking for two numbers that multiply to negative 48 and two numbers that add to 2. So again, I have a positive and a negative for my sum and my product, so my two factors, one should be positive, one should be negative. The sum is 2, so the larger number, it's positive 2, so the larger number must be positive. So we have to think about what numbers multiply to 48 but add to 2. And what we should find, 8 and 6 do work. They multiply to 48, but one of them has to be negative because the product is negative. Because the sum is positive, my larger number has to be positive. So in this case, the 6 has to be my negative because it's the smaller number. So 3, and then my trinomial is now broken up into two brackets. A is the first one, so a plus 8, then a minus 6. And so that's my factored form. I had to common factor and then factor a simple trinomial. H, again, we run into the same issue. We have a variable in front. So what we have to do, a number in front, or a coefficient in front of the variable squared, or the very first term. So I need to common factor or see if I can common factor. In this case, I can common factor a 5 out, and I'm left with x squared plus 10, not 10x, because when I take that factor of 5 out, it becomes 2x minus 3. Now I can use my product and sum, two numbers that multiply to negative 15, because we're looking at this trinomial, so the one in the brackets, the factored one. So two numbers that multiply to negative 3 and add to 2. Again, a positive and a negative, so we'll have the same thing in our factors. Because the sum is positive, my larger number should be positive. In this case, we should find 3 and -1 are my two factors. So 5 remains there. I'm going to break this trinomial up into two sets of brackets. My variable is x, plus 3 is my first number, then x, and then -1 is my second number. And that's the factored form. I looks a little different because I have multiple variables here. Oops, this one should be squared on the end. I have multiple variables here, but as long as it works out where the last one is squared and the middle two are singular and the first one's squared or some variation of that, this will work out the same. So I'm going to check to see for a common factor. I can't common factor anything. I'm going to look for my product and sum then. My product is -260. My sum is 16. My factors, one should be positive, one should be negative. The larger being positive because my sum is positive. In this case, we'll get 26 and -10. So here, when we're writing our brackets, a will be our first term plus our number, but we have to add a b onto it because that's how we get our b squared. So our second bracket is a, then -10, and then we have our b attached to the last number. In J, we don't have it in the form x squared plus bx plus c because now I have an x term with everything. But what I can do is I can factor out an x, so I get x squared plus 27x minus 58, and in this case now I can factor the inside because it's a simple trinomial. So now I'm looking for two numbers that multiply to -58 and then add to 27. My factors in this case are going to be 2, -2, and 29. So I'm going to break up the inside, or this trinomial. X is my variable, so that comes first. -2 is my one number. My second bracket, x comes first, and plus 29 is my second number. For k, again, I have a term or a coefficient on the x squared, or the number in front, so I have to common factor, or see if I can common factor. In this case, I can common factor a 2 out, so I get x squared plus 7x plus 12. Now this is a simple trinomial, so I can use my product and sum method. So two numbers that multiply to 12 and add to 7. So because my product is positive and my sum is positive, my two factors have to be positive. So in this case, it will be 4 and 3. So x is my variable, plus 4 is my one number, x is my variable, plus 3 is my other number that I found. Lastly, last example, again, it's not in the form x squared plus bx plus c, but I do see that there is something common between all of them. They all have an x, and when I'm common factoring a variable, I'm taking the lowest degree or the lowest exponent. In this case, it's 2, so I'm going to factor out an x squared. This is going to leave me with x squared plus x minus 12, which is now a simple trinomial. So I can find a product, or two numbers to give me a product of -12, but add to give me 1. Negative product means that my factors, one should be positive, one should be negative. Because my sum is positive, that means the larger number of my two factors has to be the positive one. I should find that 4 and -3 work. So the x squared stays. x is my variable, plus 4 is my first number, and minus 3 is the second number. So that is my factored form. To factor using the product and sum method, again, the trinomial must be in the form x squared plus bx, or sorry, ax squared plus bx plus c, where a equals 1. So in reality, we're not even going to see this a, because with 1 we don't have to actually show it. So you should just see x squared plus bx plus c. Some helpful tips to help us figure out what our factors are. If the product is positive and the sum is positive, both, we'll call it factors, are positive. If the product is positive but the sum is negative, both factors are negative. And if we have a product that is negative, a sum that is positive, we have one factor, or sorry, let's put it this way. The larger factor is positive. The smaller factor or smaller number is negative. And as the opposite, again, still the product is negative, but the sum is negative. The larger factor is negative and the smaller factor is positive. So that just helps you with what the signs are on those actual factors that we find. It doesn't really help you find the numbers, but it does kind of give you an idea of what signs they should be. So that might help in terms of finding out if they add or subtract to the sum. So it helps you with figuring out what your two numbers might have to be and when you play around with it. But again, the biggest thing, when you're factoring a simple trinomial, we're using the product and sum method, where we're looking for two numbers that multiply to the constant or the last number in our trinomial, and the same two numbers have to add to our middle number of the trinomial. Those two numbers are going to be our factors, and we're going to plug them in to the form x minus s times x minus t. So again, take your time, have a multiplication table handy because that will be helpful, and it just takes practice to recognize what some of the combinations are to get your numbers.